Chapter 2, linear and quadratic equations. We're going to start with the linear equations, a little bit easier to work with. Most, if not all of you, will be very familiar with solving linear equations. We move to quadratic equations. We're going to look at a couple of different ways to solve quadratic equations in this chapter. First thing, some different properties of equality. Don't worry about writing down the exact definition of these equalities. You certainly can. I'm going to show you two examples, and it should be very familiar to you. So here's the idea. The addition property of equality says that if something equals itself, 5 equals 5, then you can add 2 to both sides of that equal sign, and the truth value of that statement remains the same. So if 5 equals 5, 5 plus 2 equals 5 plus 2, which makes sense. All we're basically saying is that if something equals something else, you can add the same amount to both sides of that equal sign and keep the statement true. Same thing with multiplication. Multiplication property of equality says that if two things are equal to each other, 5 equals 5, you can multiply to both sides of that equal sign. 5 times 2 is the same as 5 times 2. Same thing works with subtraction and division. They are kind of grouping addition and subtraction together here because you can always add negatives. So it'd be the same as saying 5 plus negative 2 equals 5 plus negative 2. Same thing with division. Division could be rewritten for multiplication. Instead of 5 divided by 2, you could write that as 5 times a half equals 5 times a half. And so these two properties really cover those four basic operations. We do the same thing to both sides of the equal sign. We can use that to solve equations. If you want to pause it and work through this and remind yourself of how to solve an equation, you certainly can. But we're going to solve for x. We're going to figure out what x equals. There are lots and lots and lots of ways to do this. There's not one specific method that you have to take or order of operations that you have to do. However, there's an easiest way. And so I'm going to always try and show you the easiest way. And in this one, I'm actually going to slow down a lot, and I'm going to show all the steps involved, and I'm going to add some stuff in that you wouldn't necessarily see. And then after that, I'll do it in a more regular way. That'll make more sense as we go. Here we go. My first suggestion for solving these equations is to make sure is to get all the x's onto the same side of the equal sign. So what we're basically doing is we're eliminating the x's from one side of the equal sign and doing the same thing to the other. Now, I put a bunch of parentheses in here. That's not typical. However, I do want to express what's going on. What we're doing is we're taking this original statement here, 15 plus 8x, and we're adding negative 8x. We're doing the same thing to both sides of the equal sign. Most of you would just subtract 8x from both sides, and that's essentially what we're doing. But I'm putting these parentheses in here to show that we're taking everything on the right side, and we're adding negative 8x to it. We're taking everything on the left side, and we're adding negative 8x to it. By combining like terms, the 8x plus negative 8x becomes 0. So there's no more x's on the right side of the equal sign. And by combining like terms over here, we have negative 4x plus negative 8x gives us negative 12x. Now, some of you are thinking, why make it so complicated? In future problems, I won't. I won't add the parentheses. I won't do all that. I'll do it in a much more streamlined way. However, I just want to take this example to show what this step is actually doing. For the next part then, so I've eliminated the x's from the right side of the equal sign. Now to isolate that variable, to get x all by itself, I want to eliminate the negative 12 times negative 12, and I want to eliminate the plus 3. There's no right way to do this. What I've found anyway is the simplest way, or the least difficult way to do this problem, is to eliminate or to deal with the adding or subtracting first. So we have a multiplication and an addition. If you deal with this first, things work out more smoothly, we'll say. So to get rid of that, to eliminate this plus 3, I'm going to add negative 3 to both sides of the equal sign. And again, most of you, when you're solving this, won't write all of that out. You just write minus 3 to both sides of the equal sign. I'm just doing it in an extra step here. So I'm taking that entire piece, everything that's on the left side, and I'm adding negative 3. I'm taking everything on the right side, and I'm adding negative 3. By combining like terms here, 3 plus negative 3 is 0, and I can add these together. 15 plus negative 3 is going to give me 12. You could ask, negative 12 times something, negative 12 times x equals 12. What would x have to be to make this true? And if you just know it off the top of your head, well, negative 12 times negative 1 would be 12. Then we've got our answer. X is negative 1. However, if it's not something you just see, if it's a fraction, a decimal, if the answer is the square root of 10, you may not be able to just see the answer. And so if that's the case, it's multiplication. So we want to undo that multiplication. There's 2 ways to do that. You could divide both sides by negative 12, and that would work. I'm going to use the properties that were given before. The textbook gives the addition property of equality and the division or the multiplication property of equality. So instead of dividing both sides by negative 12, which is perfectly fine, I'm going to multiply both sides by negative 1/12, which again feels like why would you do it in such a difficult way? This is going to come back as another option later on. So rather than dividing by negative 12, I could multiply by negative 1/12, because negative 1/12 times negative 12 is the same as 1. You're multiplying and dividing. This fraction bar means divided by 12. So you're multiplying and dividing by negative 12. You're going to end up with just x. And the answer ends up being then that x is negative 1. I showed a lot of steps here. In the future, I won't show all those steps in between, but I do want to take the time on this problem to show really what is going on, why these properties, or how to apply those original properties. Okay, let's look at another example. I'm going to solve this one. I'm not going to show all the nitty-gritty steps. I'm going to do it in a much more streamlined way, but I'm going to use the document camera. So we've got 3/8 x minus 1/2 equals 3/4. So I want to isolate the variable. The x is already only on one side of the equal sign, so I'm good to go there. Teaching middle school for so many years, I draw a line here. You don't have to do that. If I want to isolate the variable, I could try and get rid of this 3/8, this times 3/8. However, I'm going to try and get rid of this minus 1/2 first. So I want to get x by itself. I want to isolate that variable. The inverse operation, the opposite of minus 1/2, is plus 1/2. The only reason that we do that inverse operation, that opposite of minus is plus thing, is because we want this to go away. We want to eliminate this from the left side. And minus 1/2 plus 1/2 is 0. We don't typically write the 0, but it's there. This plus this is 0. So we've eliminated it. And that's why we do that inverse operation. 3/4 plus 1/2. I need to get common denominators to add. I need a common label. So I've got fourths here and halves here, and that's not a common label. So I'm going to change 1/2 to 2/4. 2 divided by 4 is the same as 1 divided by 2. Now I can add them together. 3 of these plus 2 of these